Hi there. So I'm just going to do a really fast review of what your work was last week when you started this unit called relations and functions. So those two words have a lot of meaning. Basically, if you have any kind of situation where there is some kind of association between two values, it's always called a relation. So pretty much anything is a relation. Somehow one item is linked to another item. So an easy way of showing a relation is talking about coordinate points. So you have plotted points before. I'll just give you a quick example, let's say. So this is called my y-axis, this is called my x-axis, and somebody wants me to plot the point 3, 6. It's alphabetical order, so x comes before y, so this is telling me always start at 0, 0. This is called the origin. This is telling me on the x-axis go positive 3, so that would mean 3 jumps to the right. So sometimes you'll see numbers on these lines, so I would go here to 3, and the next value is a 6 and it's positive. So the next value is telling you how many jumps now to go up. So I would go 6 jumps up, 1, 2, 3, 4, 5, 6. So there could be a 6 here. So that is the point called 3, 6. So let's say I had the point negative 4, 5. So the first value is where to go on the x-axis and the second value is where to go on the y-axis. So I would go 4 to the left, 1, 2, 3, 4. Why did I go 4 to the left? Because it was negative. Then this is a y value, it's positive, so from here I now go 5 jumps up, 1, 2, 3, 4, 5. So that is that point. If somebody said, all right, now let's do 0, negative 7. The first value is x, the second value is y, so I am starting here, and this is saying go 0 on the x-axis. So I wouldn't go right and I wouldn't go left, but I would go 7 jumps down. 1, 2, 3, 4, 5, 6, 7. So that would be that point. This is a relationship. This is showing if I want to have certain dots, this is the directions for going one way, and those are the directions for going another way. So this unit started on page 389 in your textbook. It got you to talk about x coordinates and y coordinates. It got you to, you listened to a video about showing relationships. If someone gave you toothpicks and they said, okay, how many triangles can you make? That's a relationship going on. Depending how many toothpicks you have, it'll determine how many triangles you'll be able to make. So you read through all of that. Then over here, you did some plotting. This is like an x value because it's the top line, and this is a y value. So we would typically have an x here and a y here, but they're wanting us to use different letters. So that's okay. Instead of x, down here I could have capital I. Instead of y, I could have v. So these are more points. This 0.56 is just like we did over here, 0.5, 6. So I would go a half a unit. So starting here, I would go a half a unit to the right and then 6 jumps up. So I would have a point like that. So you would have to decide how you want to space this out. You know, to get to an I value of 4, it would kind of be silly just to go 0, 1, 2, 3, 4. We might as well space this out. Maybe this is always 0. That could be 1, 2, 3, 4, and then you could decide, or what that would do for you is you'd fill in more of that graph than just by counting little units at a time and ending at 4 here. Okay, so that was really your work. There's one more value they talked about, or one more concept. They talked about discrete and continuous variables. The difference between a discrete graph and a continuous graph. A discrete graph is like a bunch of dots like this and nothing is connected. So think of the word, or talking about discrete data, meaning it's really just dots. Okay, discrete data means you've got a graph of dots. If they say, no, you have a continuous function, that would mean it starts and it keeps going. So you don't have a break in it, you don't have dots, you simply have a bunch of different values connected by a solid curve. So this would be called plotting continuous data. Okay, then the next section you had to look at was ways of expressing relations. And that started on page 399. Whoop. Okay, so talking about values, these are all the different ways mathematically you can show how things are related. You could describe something in words, you could do an arrow or a mapping diagram, you could do something called function notation, which we're not going to get to this semester. A table of values you've seen before, equations, a graph, or ordered pairs. So what I was doing here, these were called ordered pairs. Okay, any of those ways can show a value, so, or show a relationship. So here is on page 400, they're showing a whole bunch of these ways to show a relation. This first value is always your x value, and this is your y value. So if I wanted to write this as ordered pairs instead, there it is right there, 20, 10. So this next line would be those coordinates. This is where you would go on the x-axis, and then this is how high or low you'd go on the y-axis. So 20, 10, they've plotted it here for you. They started at 0, they went over to 20, and then they went all the way up to 10, and they put a dot. So right now, the way this graph is looking, it looks like it's a discrete graph, but we don't know what this is talking about. This is talking about the cost of driving a car depending on the speed that you drive it at. If something is possible to have fractions, then you do need to connect dots. So is it possible to have cost being a fraction value? Of course it is. Cost of a car doesn't have to be, or cost of operating a car doesn't always have to be $5 or $50. It could be $62.39. So if fractions are possible, you would want to join these dots. Speed, is it possible to have a fraction of a speed? Or do you have to go 65 or you have to go 32? No, there could be decimals. You might be driving 65.3. So if something is given to you as dots, it's your job to decide, should you join them or should you not? If it's possible to have fractions, then you would have a continuous graph, you should join them. So in this case, yes, you should join them, and they actually showed you that over here. It would make sense to join these. But this is a relation, so all these different ways of showing a relation. We have a table of values, ordered pairs, a graph. We could make an equation. Again, we have another graph. We have words, what we're talking about. And this looks funny right now, but you'll get used to seeing it. This is the same as this. It shows you 20 connects to 10, or 120 connects to 10. That's exactly what this is saying. So a whole bunch of different ways for you to be able to talk about a relation. So is it related? Is the speed that you drive your car related to how much you might end up paying for repairs on your car? Yes, it absolutely could be. So that is an example of a relation. Okay, and I think a couple other terms. So you definitely have seen equations before. We always talk about in equations having a left side and a right side. This value for y depends on what you put in for x. If I put a 1 in here, that's telling me go 3 times 1 minus 5. So once I know what to put in here, then I know what the answer will be. So we could do lots of different examples of that. If I said to you, okay, here's an equation, y equals 3, well, we just use 3. So let's go 2x plus 1. And I want to come up with a whole bunch of ordered pairs so I could draw this graph. Well, I can randomly choose different things to put in here for x. Let's say I put in a 0. 2 times 0 plus 1, I'd get 1. Let's say I want to put in a 5 here. 2 times 5 plus 1, so if I used a 5, now I would get 11. Let's say I want to put in a negative 1 right there for the x. And remember, the x's come first. And I worked that out. I would get 2 times negative 1 is negative 2 plus 1. I'd get negative 1. Then if I wanted to maybe try negative 3 in there, I would get negative 5. I can take all those points now and plot them on a graph. And there should be a pattern happening. So 0, 1 would be right here. 5, 11, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 would be here. Negative 1 would be here. Negative 3, negative 5 would be there. Can you see a pattern? these are actually all falling along the same line because these points all came from the same relation. This is a relationship showing, depending on what somebody gives you for x, then you could figure out what the y would be. So whenever we have an equation, we say that this depends on this other side. So let's say I had negative 5x plus 7. How am I going to know what y is? It depends on what x is. So this is called the independent variable. You can put in whatever you want there. Like I did a minute ago, I grabbed 4 different values, and that will change what the result is. So this is now called the dependent value. Sometimes this is called input. Independent is input. Sometimes this is called output. So what you put in influences what you get out. But everything really then can just be written as what went in for x, what you got for y. You now have some points. So that's why this is a relation. So that was your second lesson. Then the third lesson talked about x and y intercepts. So we jump to page 413. And x and y intercepts, to intercept is to cross. So an x-intercept would be where my graph crosses the x-axis. So that kind of looks like a funny value right here, but where my graph is crossing the x-axis, that point is called the x-intercept. So it probably would be like negative 0.50. That's about that value there. Over here, this value here could be an x-intercept because it's crossing the x-axis, so its value would be 0, 0. This point is not crossing the x-axis, it's crossing the y-axis, so this would be called a y-intercept. So if I had some kind of graph going through there, and someone asked me for the y-intercept, 1, 2, 3, 4, 5, 6, 7, this would be 0, negative 7. So the y-intercept is something that touches the y-axis. An x-intercept is something that touches the x-axis. Y-intercepts stay here, so they will always have x values of 0. If I had a graph going over here, this would be an x-intercept. So that's 4, 5, 6, 7, 8, oops, 4, 5, 6, 7, 8, 9, 10, 11. So this is 11, 0. For something to be an x-intercept, it means it must be down here on the x-axis. It can't be high or low. So x-intercepts always have their y value as 0. And that was discussed on the video. So therefore, you now can do some math to figure out x and y intercepts. If I'm given this equation, and somebody wants me to find the x-intercept. Okay, so whatever this graph is going to look like, it's going to cross the x-axis somewhere. What do we know about all x-intercepts? They all have y values of 0. So that means go here, this is x, this is y, put in a 0 for the y. So 0 equals 2x plus 4. So now come your math skills. We need to get this x, we need to figure out what that value is. So we minus 4 from both sides. That eliminates this over here. Now I have 0 minus 4, which is negative 4, equals 2x. To get rid of a times by 2, I would divide this side by 2 and this side by 2. 2 divided by 2 is a 1, so I can cross that off. Negative 4 divided by 2 would be negative 2. So I just found the missing value. So if I wanted to graph this, I now know that this is the x-intercept. How would I find the y-intercept? That's easier. The y-intercept does what all y-intercepts do. They have their x value as 0. So go put a 0 in here and work this out. So this is way faster. 2 times 0 is nothing, gone, plus 4. All that's left here says y equals 4. So this point is on this graph, and it is called the y-intercept. The one we just did over here was called the x-intercept. So notice they're neat. They both have zeros in them. The y-intercept has a 0 for the x, and the x-intercept has a 0 for a y. This is enough for me to draw this graph. I can go to a grid and plot 0, 4. So 0, 4 would be here, so don't go left or right, and 4 up. Get my other point, negative 2, 0. Negative 2 is here, but don't go up or down. Can I draw my graph from those 2 points? Sure you can. There it is right there. So that is a nice easy way to draw a graph by finding x and y intercepts. Okay, so that was discussed in a lesson. They gave you lots of good practice here on page 414 doing that yourself. So how will you find an x-intercept? You'll make this y0, see what's left. How will you find a y-intercept? You'll make this x0 and see what's left. So you do a little bit of algebra there. Then the last lesson was page 415, wanting you to plot. So they gave you this big graph, but all the numbers are on it. Wants you to plot different values for a new car. So they're saying capital V stands for the value of a car. What does that depend on? Well, how old the car is, right? So T stands for the age of the car. In other words, the time probably since you bought the car. So they're saying that would be the input. These are the T values. So how about if the car was brand new, 0 years old? If I put a 0 in here, that times 0 is nothing. I would have 20,000 left. So that becomes the point, 0, 20,000. So you go down here, 0, 20,000. That's where your graph is starting. How about if it was 2 years old? You'd put a 2 in here, you do your multiplying and your minusing, and you'll get another value. As you plot all these points, you can predict what's going to happen to that value of a car, right? It's going to head down. The value of the car is going to decrease the older it gets. And your points will be on a nice line. They are related to each other. So, because they are part of a relation. So you had that one to do, and then a couple extra words here, interpolation and extrapolation. Sometimes our graphs end, but somebody may ask you to extrapolate. So once you see where a graph is heading, right? So if I looked at this red graph, and I can kind of see over here at 2, maybe that's how high I am. How about if I went off the graph? How about if somebody asked me, how high will this graph be? Not at 1, 2, 3, 4, but past where this graph is. That's called extrapolating. You're going extra beyond where the graph is. But you could do some math and you could figure out how high this graph would be here. Interpolating is going within the graph. So let's say I had a bunch of points like this, and 3, 4, this is 6, and this is 9. So I know where the graph is when x is 6, it's up here. I know where the graph is when x is 9, it's up here. How about if somebody asked me to figure out, how about if I were at 7, where would the graph be? Well, you'd estimate, right? You'd say, well, let me see if I could maybe connect these. I could then interpolate because I'm looking within a graph. And if I did this, I could say, okay, if I came up from 7, oh, looks like I'd be right here. And then I could say how high that point was. So that's not going beyond where the graph was. That was working within a couple of points that I already knew. So that would be interpolation. Okay, so there's a quick summary of some of the stuff that was covered last week. This week is a concept called domain and range. Lots of notes for you in your current week on Google Classroom. Okay, have fun.